In this video, we will show what new features have appeared in our program, in its new version 1.1. In particular, in this version it became possible to duplicate all the layers of the entire structure, by an arbitrary number of times. So, in this way it is possible to create very complex structures. As an example, we will create a structure with the formula, shown here. We will not pay attention to how useful and applicable this structure is and whether it is possible to implement it in practice at all. This is just an example to demonstrate the new features of the program. This structure consists of 3 layers repeated 50 times. Already at this stage we get 150 layers. Then 2 more layers are added to them and all this is repeated 100 times and, therefore, we get 15,200 layers. Then 14 more layers are added, and this whole structure is repeated 8 times. As a result, we get 121,712 layers. Once again, we will not consider the practical applicability and feasibility of this structure. This is just an illustrative example to demonstrate the program's new features. Since there are many layers in this example, while the computer memory is limited, we should reduce the number of calculated points on the graph. We go to the configuration file and instead of the standard 10,000 points, we will put 300 points. Since we have a central wavelength of 600 nanometers, let's put 600 right here. And since we have a normal incidence, we will set the angle of incidence here, equal to 0. Well, we will change the rest of the parameters in the program itself. Now we run the program and we see that we really have a wavelength of 600 nanometers and a normal incidence. Now let's change the materials of the layers and find their thicknesses. We see that this structure consists of quarter wave layers. Let us first find a quarter wavelength thickness for tellurium. We get about 26 nanometers for this wavelength. We will remember this number, while other quarter wavelength thicknesses the program will insert itself. We will put the first layer, and the second layer here. Indeed, we get these quarter wave layers. Now let's move on to step 2. But in step 2 we will change the number of layers to 3. Now we see that this is the initial structure, which we need, according to our assignment, and here we will set air. And now we use our new feature in this version, this is that we can repeat this structure the number of times we need. In this case, we repeat it 50 times. And we see that we have 150 layers now. Then we need to add 2 more layers. How to add a single layer has been explained in previous videos. Let's duplicate 2 layers. We should have 1 layer with a low refractive index. That is, we have quartz here and its thickness is the same as that of other quartz layers. So, now we have 152 layers and we must repeat them 100 times. Which is what we do. We are waiting for this number to change to 1 again. This means that the layers have been repeated. Now we need to add 14 more layers, which we will do. The first layer will be the tellurium layer. And its thickness is 26.42. Next we add 13 layers. We just repeat the last layer 13 times. Now we have added 14 layers here and some of them we need to change to low refractive index layers. Accordingly, we also change the thicknesses of layers with a low refractive index. The structure ends with a layer with a high refractive index. Now we have 15,214 layers. And we want to repeat all these layers 8 times. We launch this process and wait. We are waiting for this number to change to 1. The waiting time depends on the power of your computer and the amount of RAM. We're just waiting. There are 16 GB of RAM on this particular computer. If you are going to work with such a huge number of layers often, then you may need a more powerful computer and more RAM. At the same time, we need to watch that the memory, which is used by the program, does not go beyond 16 GB in this case. We're just waiting here. So, we see that our total number of layers has become 121,712. The number 1 has just appeared here. That is, we got the design of the structure that we're looking for. Now let's see what we have just obtained. To do this, we start plotting the transmission and reflection spectra and wait until they are calculated. Here, as well, it is important to watch that the amount of used RAM does not go beyond the actual RAM you have. So, it is important to watch that there are no swaps to the hard disk, otherwise it will greatly slow down the execution of the program. In this case, it is better to further reduce the number of calculated points. Here we are just waiting. So, here is our program calculated this structure. The reflection spectrum of the structure looks like this. If the number of points were more, then the spectrum would look more beautiful. But even with this number of points, we can see in more detail here what kind of peaks we have. Therefore, let us calculate, for example, a part of the spectrum from 620 nanometers to 690 nanometers. We start and wait. Again, we look so that the memory does not go beyond 16 gigabytes. So everything is fine. So, the results appeared, and we see that we have such periodic peaks. It's all for today. This was a demonstration that in the new version of 1.1 it was possible to duplicate all layers entirely. And this makes it possible to calculate such a complex structure. It is clear that you can save these complex structures as a binary file so as not to repeat this procedure a second time. You can also write them for yourself as a text file, for a record. So, next time you will not necessarily repeat the creation of this structure. It will be enough to load this structure from the recorded binary file. That's all. Bye.